The idea of the first derivative has myriad applications in various disciplines. Here we're just going to talk about a few, and in this video we'll talk about an application to physics talking about position and velocity. So suppose we have a function s of t which gives the position of a particle at any time t. The derivative of this function with respect to t, the derivative of position with respect to time, gives the velocity of the function. As it turns out also, if you take the derivative of the velocity of the function, this gives acceleration. So acceleration would be something called the second derivative of position. We haven't really talked about second derivative yet. We'll talk about that more in the next chapter. So, for example, a classic position formula from physics, s of t equals s0 plus v0t plus 1/2 a t squared. If we take a derivative of this, s prime of t, which equals v of t, we get a 0 from taking a derivative of the s0. Derivative of v0t is just v0. And then we get a 1/2 a times 2t. And of course that simplifies. The 2 and the 1/2 cancels. So this is v0 plus at. And this is a familiar formula for the velocity at any time. So this is one example of where derivatives can be helpful.